Hello everyone, I am Anand Prakash Pawar. Under the guidance of Ashwin sir, I am presenting on the topic of feedback carburetor system. First, introduction to the feedback carburetor system. The feedback carburetor systems are types of fuel delivery system that uses oxygen sensor to monitor exhaust gas composition and adjust fuel delivery accordingly. These systems are designed to optimize engine performance and reduce emission. Mainly, oxygen carburetor mixes air and fuel for the engine. The oxygen sensor monitors exhaust gas oxygen levels and sends to data to the ECU. The ECU calculates the air fuel mixture based on the sensor data and engine operating condition. The ECU adjusts the carburetor air fuel mixture by controlling the fuel injector and airflow. The main goal of uh, feedback carburetor is optimizing air fuel mixture for efficient combustion, reducing emission by ensuring proper fuel burning, and improve engine performance. Then principle of feedback carburetor. Closed loop control. Feedback carburetor operates in a closed loop system where the oxygen sensor provides feedback to the carburetor control unit, which adjusts the fuel air mixture. It means the sensor, uh, for example, oxygen sensors or airflow sensors, monitors engine performance and exhaust gas composition. The electronic control units, means ECU, process sensors data and compares it to the desired value. The ECU adjusts the carburetor system setting to optimizing the air fuel mixture. The process repeats continuously, ensuring optimal engine performance and efficiency. Then air fuel ratio adjustment. By monitoring exhaust gas oxygen content, the control unit adjusts the fuel air mixture to maintain an optimal ratio, improving engine efficiency and reducing emission. It means monitoring airflow and fuel flow rates, adjusting the fuel injector pulse width and the airflow to the maintain the ideal air fuel ratio for ensuring the proper fuel optimization and mixing the efficient combustion. The next, dynamic adjustment. The oxygen sensor constantly monitors the exhaust gas and adjusts the fuel air mixture dynamically, ensuring optimal engine performance under the varying operating conditions. That means dynamic adjustment refers to the system ability to adapt the changing engine operating condition, such as total position and engine load, engine speed and temperature, altitude and atmospheric pressure. Likewise, then emission reduction by maintaining an optimal air fuel ratio. Feedback carburetors significantly reduce emission of harmful pollutants such as carbon monoxide, hydrocarbons, and nitrogen oxide. It means ensuring proper air fuel mixture, reducing unburned fuel emission, that is, minimizing the excess oxygen, reducing NOx emission, and reducing carbon monoxide and hydrocarbon through the optimal combustion. The next is component of feedback carburetor. Mainly the carburetor body, the main housing of the carburetor, containing the fuel metering system, air intake, and the throttle oil. The carburetor body is mainly housing that contains the fuel metering systems and airflow passages and other components that likewise airflow intakes, that is draws in air for the engine, fuel blow that used for store fuel for the engine, and throttle valve. that regulates airflow into the engine. The next one, fuel metering system. This system you controls the amount of the fuel delivered to the engine, including the main jet, idle jet, and the accelerator pump. In fuel metering system, it is responsible for delivering the correct amount of fuel to the engine based on the airflow and the engine operating condition. That includes the fuel injector that's spray fuel into the airflow. Then fuel metering valves that regulates the fuel flow to the injector. Fuel pressure regulator that maintains the consistent fuel pressure. Then oxygen sensor. Oxygen sensor located in the exhaust manifold. The oxygen sensor measures the oxygen content of the exhaust gas and sends signals to the control unit. The next, fuel delivery and air fuel ratio control. Mainly, it contains five steps that intake air, fuel metering, mixing, oxygen sensor feedback. Then last one is fuel adjustment. First one, intake air. In intake air, air is drawn into the carburetor through the air intake and passing through the air filter. That means air is enters the carburetor through the intake manifold. Airflow sensor monitors airflow rate and sends data to the ECU. Airflow passes through the venturi and creating a vacuum. Then metering. In the fuel metering was regulates the fuel flow based on the ECU commands. Fuel is drawn from the fuel blow into the fuel metering valve. And the carburetor meters the fuel based on the engine load and speed, delivering it to the intake manifold. Then mixing. The mixing and the air mix is the carburetor, forming a combustible mixture that is drawn into the engine cylinder. In mixing, fuel is sprayed into the airflow by the fuel injector, and the air and fuel mix in the venturi, creating a precise air fuel mixture. Then mixture enters the engine cylinder for the combustion. The next step is oxygen sensor feedback. The oxygen sensor monitors the exhaust gas composition and sending signals to the control unit. Then next one, fuel adjustment. The control units uses the oxygen sensor feedback to the adjust the fuel metering system, optimizing the air fuel ratio. In fuel adjustment, ECU adjusts the fuel metering valve to the increases or decreases the fuel flow. Adjustment maintains optimal air fuel ratio based on the oxygen sensor feedback. That is continuously feedback loop ensures optimal engine performance, fuel efficiency, and the emission reduction. The next is oxygen sensor and feedback loop. Exhaust gas monitoring. The oxygen sensor continuously monitors the oxygen contents of the exhaust gases. It means oxygen sensor located in the exhaust manifold monitors oxygen levels in the exhaust gases. The sensor measures the difference between the actual oxygen levels and the ideal levels. That is air fuel ratio. Sensor output voltage indicates if the mixture is more or more air or more fuel. Likewise, then signal transmission. The oxygen sensor sends signals to the control units indicating the air fuel ratio. In signal transmission, oxygen sensor sends the output voltage signals to the electronic control units. That means ECU. A signal is transmitted through wire or wireless connection. ECU receives the signals and interprets the data. Then next one, control unit adjustment. ECU uses the oxygen sensor data to adjust the fuel metering for. If the mixture is rich, ECU reduce the fuel flow to the lean out the mixture. ECU continuously adjusts the fuel metering valves to maintaining optimal air fuel ratio. Then next one, optimal air fuel ratio. In optimal air fuel ratio, the feedback loop ensures that the air fuel ratio remains at the ideal level, optimizing engine performance. ECU aims to maintain an air fuel ratio continuously. Feedback loop ensures that the engine operates at the optimal air fuel ratio. Then advantages of feedback carburetor: improve fuel efficiency, then reduce emissions, enhance performance, reduce maintenance. In improve fuel efficiency by optimizing the air fuel ratio, feedback carburetor helps engine burns fuel more efficiently and recording fuel engine, reducing fuel consumption. Then reduce emission. In reduce emission, feedback carburetors significantly reduce emission of harmful pollutants, that is carbon monoxide and NOx. Likewise, improving air quality, uh, precise air fuel ratio control, minimizing excess fuel and oxygen. In enhanced performance, the optimal air and fuel mixture leads to smoother engine operation and improve overall performance. Improve throttle response and engine smoothness, better acceleration and overall engine performance. Likewise, then reduce maintenance. By feedback carburetor requires less frequent maintenance compared to the traditional carburetor system. Continuous feedback loop detects and adjusts for changes in engine operating conditions that reduce risk of engine damage from incorrect air fuel ratio. Then next one is emission reduction with feedback carburetor. As compared to traditional carburetor, the emission reduction is less as compared to traditional carburetor. Maintenance and troubleshooting, that is regular maintenance. Mhm. In regular maintenance, uh, regularly inspect and clean the carburetors, air filters, and oxygen sensors to ensure optimal performance. In regular maintenance, check and clean the air filter regularly. Inspect and replace the fuel filter as needed. Inspect the carburetor and fuel system for the leakage or damages. Uh, to say to say about the troubleshooting, identify symptoms, that is poor engine performance, rough idling, decreased fuel efficiency. Likewise, or isolate the problems related to fuel system, ignition system, or oxygen sensor, etc. Then fuel system issues, the check for fuel leakages, fuel lines, and problem with the fuel pumps. In oxygen sensor uh, malfunctions, uh, faulty oxygen sensors can causes problem with the fuel delivery and engine performance. So, incorrect oxygen sensor installation because of faulty or damaged oxygen sensors. And the next one is a comparison to the other fuel delivery system. Uh, in that, feedback carburetor is compared with the fuel injector. That is, fu- in say in short, the feedback carburetor is improve fuel efficiency, reduce emission, and simpler design. A fuel injection, precise fuel delivery, better emission control, adaptable to the different engine types. It is more complex design, higher cost, require specialized tools for maintenance. And feedback carburetor is less precise control than the fuel injector, can be prone to be issues in cold weather. And conclusion and future development. Conclusion say about to the fuel feedback carburetor. Mainly, feedback carburetor have revolution fuel delivery system, providing significant benefits in the fuel efficiency, emission reduction, and engine performance. Their ability to continuously monitor and adjust the air fuel ratio has made them a crucial component in modern engine. Responsive feedback carburetors, reducing emission and environmental impact, mainly focus for reducing emission and environmental impact. Thank you, everyone.